In 1926, a German scientist by the name of Otto Warburg made a historical discovery. He was testing to see why cancer cells grew so much faster than normal healthy cells. He expected to find that the main reason for their faster growth rate was that they could generate more energy through consuming more oxygen than a normal cell. But when he tested it, he found the rate of oxygen consumption was no different between the two types of cells, but the production of something called lactic acid was 7,000% higher in cancer cells than in normal cells.
To spare you a trip back to high school biology, a normal cell can use either fat or sugar as a fuel source.
When it uses sugar, a byproduct of that process is the production of lactate, the same substance that Warburg discovered was in abundance in the cancer cell. This meant that for some reason, the cancer cell preferred to use sugar as a fuel source, even when fat was present. This preference for sugar by a cancer cell became known as the Warburg Effect. But what does the type of fuel a cancer cell uses to grow have to do with living a long and healthy life? The study of how our bodies utilize fuel is the study of human metabolism. The Warburg finding suggests that a core underlying cause of most forms of cancer is fundamentally metabolic in nature, that somebody with a healthy metabolism would be at lower risk of developing cancer than somebody with an unhealthy metabolism. Since cancer and heart disease are leading killers in modern society and both have a metabolic component to their underlying cause, it makes sense that by understanding the metabolism and how to make people healthier, we understand how to live longer and more disease-free lives. But what exactly does an unhealthy metabolism look like? To answer this question, you need to look no further than,
well, your breath.
As I sit here recording this video, I am inhaling oxygen and exhaling carbon dioxide. The ratio of how much carbon dioxide I produce breathing out divided by how much oxygen I consumed is known as my RQ, or respiratory quotient. When your metabolism primarily burns sugar, carbon dioxide is a byproduct, so the amount of carbon dioxide you exhale increases, making your RQ higher than if you're burning less sugar. If you are burning exclusively sugar, your RQ is 1. In other words, for each unit of oxygen consumed, you expire the same amount of carbon dioxide. However, your body can use fat as a fuel source, which does not result in CO2 as a byproduct, resulting in a lower amount of CO2 exhaled and a lower RQ. People burning almost exclusively fat have an RQ of about 0.7. So in short, people who have unhealthy metabolisms burn a lot more sugar than fat, and somebody who's healthy is able to burn a lot more fat than sugar. Therefore, if there was a group of people who chronically burn sugar, we would expect to see a much higher risk of cancer than those with healthy metabolisms. And it turns out that group does exist: type 2 diabetics. Type 2 diabetes is defined as a chronic and dangerous elevation in blood glucose and is associated with a 2 to 3-fold increase in your risk of dying from any cause, heart disease, and cancer. To put that into perspective, that's almost the same increase in risk of cancer that you would see in a chronic smoker. So if type 2 diabetics are the definition of a group of people with unhealthy metabolisms, who has a healthy metabolism? We already established that these people must be amazing at burning fat and have almost no preference for burning sugar unless absolutely necessary. It turns out the answer is pro cyclists. To understand why, we have to look into how the body's metabolism responds to exercise. Imagine your body as a car with 2 fuel tanks, one very large and one very small. The large fuel tank takes only diesel fuel, while your small tank takes high-octane airplane fuel. As you start to put your foot down on the gas pedal, it uses diesel because what you're demanding of the car doesn't require any high-performance fuel as long as you're driving gently. Thus, your car will only require the use of diesel. However, let's say you floor the accelerator to merge onto a freeway. When this happens, the car completely stops drawing fuel from the diesel gas tank and relies only on the high-octane fuel to handle the rapid increase in demand. This is great for a short time, but quickly this fuel tank is empty, leaving you with only diesel to handle the demands. So to take this back to human beings, a type 2 diabetic has no access to their diesel tank, so they are chronically relying on their high-octane fuel just to survive at rest, while the pro cyclists can use diesel even when they're doing the equivalent of flooring their accelerator in, say, a bike race sprint. The key difference between these two groups is something called mitochondrial function. Each of our cells have little energy factories that handle the production of energy for the cell. These are called mitochondria. When the mitochondria do not function properly, the cell has to rely on sugar to pay the energy bill of that cell. When the mitochondria do not function properly, they cannot make good use of their diesel fuel, also known as fat. So instead they have to rely on sugar to pay the energy bill of that cell. This dysfunction multiplied across all the cells in a human body is the big difference between a pro cyclist and a type 2 diabetic. A researcher at the University of Colorado named Inigo San Millan found that not only do pro cyclists have better functioning mitochondria, they have more of these energy production plants in each cell, and they are 2 to 3 times bigger than the ones found in the diabetic. So how do we improve our mitochondrial function? The answer is Zone 2 exercise. Zone 2 exercise is defined as the intensity at which you burn the most fat that you can through your mitochondria. The idea behind this form of exercise is that as you get better at doing Zone 2, you can increase the amount of power that you put out, or the speed at which you run, or the speed at which you swim with the same heart rate, meaning that your body is making better use of fat as a fuel source and is becoming more efficient. This is the definition of improving your mitochondrial function, because going back to what we said earlier, the more fat you can burn, the better your mitochondrial function. Your Zone 2 can be found using the so-called talk test. To do the talk test, you first start by exercising in some way. It could be walking or running or biking, and you continue to increase the intensity until you can no longer talk. You know you found your Zone 2 when you can carry out a conversation while exercising, but with some level of strain. So you're able to muster full sentences, but you really wouldn't prefer to if you had the choice. You know you're beyond your Zone 2 if you're struggling to string a few words together. So how much Zone 2 do you have to do in order to see a meaningful benefit in mitochondrial function? Unlike other forms of training such as resistance training, your Zone 2 capacity takes a rather long time to develop. According to Inigo San Millan, the researcher from the University of Colorado studying Zone 2 exercise, he has seen that 4 1-hour sessions per week of Zone 2 exercise is enough to really start to see some improvements in your mitochondrial function. That exercise could look like walking, running, swimming, the elliptical, stair climber, anything that you really like to do for exercise, and the intensity would be dependent on your own previously mentioned talk test. So while it's difficult to nail down the exact amount of benefit you'll get from doing that amount of Zone 2, we absolutely know that by avoiding diabetes, you are opening yourself up to a much longer life with a lot less disease and a lot less complications. But a study published in 2011 in the International Journal of Sports Medicine found that pro cyclists live on average 8 years longer and up to 14 years longer than the general population, while another study published in 2010 found that power-only athletes, such as competitive weightlifters, lived significantly shorter lives than the general population. Now, I want to stress that while these data are interesting, they are not conclusive, and there is certainly no longevity benefit for those who avoid muscle mass and resistance training to try to get some sort of lifespan extension. But if you are looking for a form of exercise that gives you the most bang for your buck, there is certainly a strong case to be made that Zone 2 might be it.
Thanks for watching. Please like and subscribe to see more videos just like this.